Okay, let's keep going with the introduction. Manufacturing processes. There are basically just two types of processes. There's a processing operation, right, where you change the shape, or you do something chemically to change the properties, or you can just change the appearance. Something that changes the product itself. And then assembly, you really don't change any of the geometry or anything like that. You just put it together, right? You start joining it together. So this is a picture of some guys putting together a top of a rocket. Again, I'm not going to go into much detail on these. I'll have some videos, but basically you got shaping operations. This is, you just change the geometry. Put it on a lathe, you turn it, you bend it into a pipe, um, you flatten it down into a sheet metal, something like that. Property enhancing operations. This will be in the discussion forum. Come up with an example of this again, right? You change the physical properties without changing the shape. So it stays the same, you just change the properties of it. And by properties, we mean somehow the chemistry, the mechanical properties of it, just something changes about it without changing shape. And surface processing operations. Uh, we actually got a factory that takes sheet metal and puts on the paint for appliances. So like you get a refrigerator, it's got some paint on it. It could have been done in Jonesboro. I don't know. I worked with them a bit. They had trouble with mosquitoes getting onto wet paint and leaving little mosquito prints on it, which is a flaw, and they had to throw out a bunch of metal that way. So we figured it out. See if you can figure out how to keep mosquitoes off paint. There are basically four shaping processes, the categories: solidification, particulate processing, deformation, and material removal. And I have some more slides. They'll discuss these in detail. In the previous unit, there was a video on casting. Uh, that's an example of solidification process. You can also do that with plastic, where they kind of melt these plastic beads, and then they shape them into whatever they need to shape them into. But basically, you go from a liquid into a solid um, or very plastic state. Think of rubber gloves. So this is particulate processing. This these little cartoons on this slide that shows sintering. Basically, to start out with powdered, just powdered metal, right? Stick it in some kind of mold, right? Press it together, heat it up a little bit probably. So they stick in that die, and what spits out is this solid metal bit, right? Not as strong usually as alloys and metal that's turned, but right place, this thing's pretty good, right? Sintering is a method for making objects from powder, right? Heating the material until particles adhere to each other. That's sintering. So deformation, well, this is where the work part is shaped by, you apply a lot of force to it, like a big press or something, until you exceed the yield strength of the material. By yield strength, if you think of a paper clip, right, and you just pull it out just a little bit, one of the pieces of metal, it'll snap back into the paper clip shape. If you pull it out too far, it doesn't snap back. And we say that the material is yielded. In other words, it won't snap back into its original shape. So an example would be, there used to be a Kohler factory in Searcy, Arkansas, and they made stainless steel sinks. And they'd stick this big sheet of stainless steel sheet metal into a press, 40-ton press, and it'd come down and it'd spit out a something like a sink, stainless steel sink. There's a lot that actually goes into that, figuring that out. It's not there anymore. One of the guys bypassed the safeties, got his head in the press, and didn't work out so well for the guy. 40 tons on your head, the press is going to win. But that's yield strength, and that's deformation. Oh, and by the way, you can do this also with plastic. Anything that'll change the shape of the metal, making like wires thinner and thinner and thinner. That's extrusion. That's an example of this too. Material removal. Basically, if you got whatever the material is, just it doesn't matter, metal, plastic, wood would be an example. If you're making chips, you're doing material removal. So some examples: you got the turning, like a lathe, drilling, milling, grinding, and you can do some stuff with non-traditional methods. Lasers are a big one now. Where you burn off the material. But if you're removing material and you're making chips, this is your process that you're doing. We're going to talk about this in depth about waste. This is a non-value added. If you're making scrap, you're losing money. So you want to minimize that, right? So, you know, casting, things like that. I worked for a company that made copper tubing. And they didn't realize how much money they were throwing away. They said, well, we remelt it so we really don't lose anything. But basically only about 20% of what they started off with made it to the end. So, yeah, if you're doing that, you're wasting money because you still got to heat it up again to remelt it and things like that. Some different terminology, net shape processes. It's when you get the starting material and no subsequent machine is required, near net shape processes. This is when you do the minimum. When we used to make casting for hydraulic valves or design them, we would go to the foundry and say, this is we want the mold, and we get it nearly as close as we can to where it looked like the finished product, so we wouldn't have to make so many chips off it. Property enhancing processes. You don't change the part, you just change some kind of property on it. Mechanical, in other words, you know, we talked about that yield point, you change that, or the physical properties, it looks different, it's got different colors, something like that. You don't change the shape though, unless you have an accident. For an example, heat treating, that's an example of changing the mechanical properties of the material. If you work in a steel mill, there's a very obvious example of this one. Or if you work in other factories, a bunch of other examples. Instead of me giving you some, I've deleted that part. Let's list them in discussion. Again, use the internet on this. Surface prep, right? Surface processing operations, cleaning. This is where you remove dirt, oil, anything that makes it dirty. I used to use Freon for that until we found out it was eating up the ozone layer. But now it's anything that makes it clean. This is actually a very big, especially when you paint something, you gotta make sure it's very clean. And surface treatments, so sandblasting, diffusion, that's where you put a chemical on and it kind of floats in. You can put a patina on it, mechanical, right? So whatever that is, the surface looks different after you do something mechanically to it. Coating and thin film deposits. This is where you, well, again, we got that sheet metal. They paint it, right? They just paint it, and that's basically what they're talking about here. So, Okay, assembly operations. This is where you put two or more separate parts into a new entity, a whole new product. A couple types. Joining process, where you create a permanent joint. Welding, we all know what that is. Brazing and soldering, not so much anymore, because if a material it has to be brazed or soldered. Generally, it's made out of plastic now. And adhesive bonding, you epoxy a couple pieces together. Okay. Mechanical assembly, you see those nuts and bolts there. Basically, you just thread fasteners, or you can press fit things together, or you got expansion fits. Um, if you think of it like bearings, right? You keep them in the freezer, well, the bearings will shrink, and then you take them, you just press them into the race. That's an example of a mechanical assembly.